So with the field of geriatric science, the thought process is that there's changes in biology that happen that then express to all these different diseases. That ultimately, if these mechanisms were able to be delayed or expressed differently, then a person would live longer and have less disease. And when we look at the different areas of organ decline with age, one of the key things is atrophy of the brain. So we'll be looking at cognitive resiliency, signs of mild cognitive impairments. People get older, different organs get impacted. For example, the alveoli, where we use to saturate our lungs with oxygen, they become smaller over a period of time. Our heart tissues change, they become less functional over time. Our blood vessels start to harden, different organs get to get smaller. We're going to talk about that specifically and all the things that are happening to our physiology, organ by organ, in the next lecture. But what we really want to focus on right now is what are called the hallmarks of aging. So if you do any kind of reading into aging and longevity, you're going to have these common mechanisms listed over and over again. These all then change the expressions of cells that then lead into aging. So genomic instability, that's really when the genes start to get damaged faster than getting repaired. Telomere attrition, that's where the tips of the chromosomes get impacted. So cell division, over each cell division, as they get shortened, you get less epigenetic expressions or efficiency there, alterations of epigenetic expressions. And you can see these kind of like start to feed into each other as well. Decreased epigenetic expressions, meaning how cells efficiently communicate and send messages. Loss of proteostasis, making proteins and also getting rid of proteins. So you get a lot of protein aggregates with loss of proteostasis. Dysregulated nutrient sensing, that's the pathways where you basically control appetite, how insulin is secreted, how growth hormone is secreted, how they impact bioenergetics, the actual function of the mitochondria making ATP, how cells finally stop go into cell division and stop functioning, cellular senescence, and then stem cells just being exhausted and not being able to apply new lines of cells, and then altered cellular communication. So those are all the molecular hallmarks of aging. And then you'll see all these are just stacked up into one slide, which we're going to go over one by one and go into these in much, much more detail. So you really understand what these terms mean if you're not familiar with them. And in the field of longevity medicine, in addition to hallmarks of aging, they also use pillars of aging. And pillars of aging, there's some overlap between these two. So we'll cover all the hallmarks of aging, and then we'll talk about which ones are overlap. And then we'll go over each one of these individual pillars of aging that have not been mentioned, hallmarks of aging. And this way, if you start to read some of the longevity papers that you have in your course materials, or start to read what's out there in the literature, you have a pretty good background with these mechanisms and how they relate to cellular aging. So let's go over the hallmarks of aging first. Hallmarks of aging, we're going to first start with the first four that cause cellular damage. These mechanisms are all causing some kind of tissue damage, right? So they're the hallmarks of tissue damage. We'll start with genetic instability. So ultimately, our DNA is always under attack. Some estimates are there are 70,000 attacks against your DNA just from your endogenous body, not including any external factors. So all the different cellular responses in our body, some create inflammation, some create free radicals, and those things can damage DNA. And if DNA gets damaged greater than it can be repaired, and they have this balance of increased damage of DNA, that's one of the mechanisms that is then leads to unhealthy cell development. Cancer cells are not functional. So one field of geroscience is what they call genomic maintenance. Genomic maintenance is the ability for the genes, even though they're injured, to repair. So one part of genomic maintenance is destruction itself. So chemicals, UV radiation, constant exposure to those things, reactive oxygen species, they do damage DNA, right? So when people do get exposed to these things over a period of time, they accumulate. And it's this accumulation that causes these DNA changes. If you remember your basic DNA physiology, we have a chromosome opens up by helicase. You get this ligand strand that prevents it from uncoiling, and then you have all these nucleotides add and have all these cellular processes that take place throughout our DNA replication process. Now, when we look at damage to our DNA and things like solar radiation, sun, combustion products, like air pollution, pharmaceuticals, even pathogens and viruses, they can come in and damage the DNA in various areas. They can cause damage with the strands themselves. They can impact one or single or double strand impacts. They can cause adducts or things to come in to get in the way of normal signaling. Some viruses can link in right into different strands of DNA. And when these different types of toxins come in, these are called genotoxins, right? So a big field of cancer research is genotoxins. But aging physiology is also associated with genotoxins. The more genotoxins we get exposed to, the more damage we get to our DNA. And when you look at these things, it's obvious we know that these things are bad. We may not be able to look at some of the impacts of them. So remember when the nuclear plant in Japan busted loose and there's radiation that was being leached into the ocean, that's never stopped. That radiation is still being released all over the world. So we're getting higher exposure to radioactive byproducts, and those things are impacting our DNA, especially closer we are to those sources. And there's so many other variables and things that are happening like that. And this destruction of DNA strands that take place then can lead to these different expressions. Here's a cell microscopy picture of radiation DNA strands. These are healthy DNA strands. And then they expose them to radiation. And then you can see just within a few minutes, they start to break open. And just a little zap of radiation causes these things to be exposed. Now, the expressions of these DNA damages, you can see all the time. This is a picture of a 69-year-old man who drove a delivery truck for 28 years. Damaged skin on the left side of his face because the sun is constantly exposed to the left side of his face. So those cells are getting UV light DNA damage that is now changing the expression of those tissues, which can visibly be seen. So one of the things we're also going to talk about is looking at facial appearance. There's a lot of research that shows facial appearance could be a good way to evaluate biological age, not chronological age, but biological age. And there's overlap in chronological age, of course, but you want to really get an idea of their biological age. So here, if you were to just look at his right side of his face, you would think he's a different age than if you looked at the left side of his face. This is a visual expression of DNA damage, UV light being genotoxic, breaking the strands of a period of time. And then the expression of those tissues and their cell division are different. So now they have this aged appearance. Now here you can see just the diagram. You have endogenous factors that are damaging DNA. So the more systemic inflammation you have, if you have an inflammatory disease itself, or even exogenous factors like you're around high degree of air pollution, for example, those things start to damage DNA. If you live in a busy city, you can have much more exposure to exogenous genotoxin factors than if you don't. So the more dense people are to you, the more exogenous DNA damaging compounds you have. And these things basically start to damage DNA. You get genome instability, and then you get inefficiency of those cell cycles and cellular communication pathways, and these are linked to aging, cancer, and degenerative diseases. So here's another illustration of the same thing. Aging, you get accumulation of immune genomic rearrangements, deregulation of transcriptional responses, decline of DNA repair, and then more mutations. Now, when you look at these free radicals are really consistent. Now, let me ask you a question. Could you even design a study design where you would give someone antioxidants and see if they developed aging over a period of time? How would you do that? It would be extremely difficult, like not impossible. Where you would look at someone taking, let's say, resveratrol every single day, X amount of milligrams for 40 years, and do they have more aging or longevity than another person? And how consistent were they? How many people followed through with the clinical trial? How many people dropped out? How many other confounders were there? It'd be difficult to do. So one of the things I would encourage you to do is when you really look at these things, you should really bump up your antioxidant systems. Because really, whether it's endogenous or exogenous, the only thing that really protects us is our antioxidant defense systems. Now, you can raise your own antioxidant defense systems by physical exercise and movement. That'll raise your antioxidant system. Saunas, cold plunges, we're going to talk about those types of therapies. They can increase your system to produce more antioxidants. Foods you eat that are high in flavonoids can provide antioxidants to your system, and then taking nutraceuticals. So that's like a key thing. So your antioxidants come in, they help with this pathway. And then this DNA repair, where your body can go in there and repair these strands together and make them work, will be ideal. That's part of genome stability. And what's required to make these DNA repair, or called the cold shock proteins. And guess where you get cold shock proteins from? From being in extreme cold temperatures. So what's become really popular is people that are doing cold plunges or using ice baths. And of course, people have always used them in the past for injuries, like athletes who would go into an ice bath after a professional game or practice or something. But now we're finding is being done regularly can have some benefits of how, first of all, how people feel and their energy levels. But it's one of the few ways we know of where you can activate these cold shock proteins that then actually help repair DNA. So even though you get exposed to different chemicals, and obviously we want to try to reduce our chemical exposure, optimize our biotransformation of getting rid of chemicals, bump up our own antioxidant systems, take antioxidants, eat foods that have high amounts of antioxidants in them, high flavonoids. We can also look at strategies like things like cold thermotherapy to start promoting these DNA repairs. So these are the things that we're going to talk about when we talk about clinical applications to longevity medicine, and definitely thermotherapy with either cold plunges and saunas can impact some of these pathways. Now, cold plunges are going to release cold shock proteins that help with DNA repair. And then things like saunas are going to activate things like heat shock proteins that will help with autophagy. They're a little bit different. So here's another diagram. It's really showing you like endogenous, exogenous sources. Again, endogenous sources being just mitochondrial metabolism. And this is, for example, where caloric intake comes in. The more food, so when you eat food, that food eventually becomes glucose. That glucose eventually goes into the cellular process to make ATP. As the mitochondria makes ATP, it also makes free radicals. So the higher food consumption a person has, and the more inflammation they have in their body, the more reactive oxygen species they develop. And that with the amount of pollution they have is only counterbalanced by their antioxidant system, whether they make it themselves or they get it from foods. But this is essential. And one of the things I would just encourage you all to take is you should definitely be taking antioxidants. And the question is, how much? There's always two worlds to talk to. I can tell you what I mean by that. So as an educator, I have a person talk to me as a clinician. I might have a different response to them than if they're a patient. Because in a patient setting, you're trying to do the best you can, make sure that they feel comfortable. You're not trying to get them to be overwhelmed. You're conscious of their expenses. And then with practitioners, that's not the issue. They're just trying to go, what do I need to do for myself? And I would tell you, what you need to do for yourself is you need to take a lot of antioxidants. And how much? As much as you can, of various different types. Here's how much antioxidants you take. Take your hand out, grab a bunch of different ones, and just fill it. Yeah, that feels good enough, and just take it. It's maybe like 100 milligrams or 200 milligrams. Get diverse amounts and load up. You should do your antioxidant hand fill every day and just load up on antioxidants preventively. I think it will serve you in the long run in many different ways. But one of the key ways is it helps against DNA damage. And once you get DNA damage, you can only have so much repair.
If you're a licensed healthcare practitioner ready to evolve your functional medicine practice, explore over 300 hours of clinical training, masterclasses with leading functional medicine clinicians, and certification pathways. Or check out the Academy of Functional Nutrition and Lifestyle Medicine at afnlm.com. Whether you're on the path to certification as a functional nutritionist or simply want to optimize your own and your family's health, our skill-building approach builds real-world competence from the ground up. And lastly, if you're dealing with chronic health challenges, visit drknews.com for self-paced courses that help you understand and address fatigue, brain fog, autoimmune conditions, gut problems, and more using evidence-based approaches. The content on this podcast is for educational purposes only and is not intended to diagnose, treat, cure, or prevent any disease. Always consult with your healthcare provider before making any changes to your health regimen. Thanks for listening, and don't forget to subscribe and share with someone who might benefit.